Hello everyone, welcome back to the another session in Principles of Programming Languages. The topic name is Attribute Grammar. This topic you will find in first unit as topic number 12. Now, before we step into know about what is attribute grammar with some examples, let us talk about why all these kind of grammars are required. To attribute grammar is a device used to describe more of the structure of a programming language that can be described with a context free grammar. Here I have used a word which is more of the structure. That means the things which are not defined using in any of the grammar over here, that is going to be defined in attribute grammar. Now let's understand what is this more of the structure which can be described using attribute grammar. Now, so attribute grammar is what? An attribute grammar is a device used to describe more of the structure of a programming language that can be described with a context free grammar. So what we'll be going to do exactly is we'll be going to define an BNF again. The BNF added with the more of the structure is leads to call you attribute grammar. Now let's see about that. Before we'll see about static semantics. What do you mean by the static semantic? There are some characteristics of the structure of programming languages that are difficult to describe with BNF, as I have discussed in the very beginning of this presentation. As an example of a syntax rule that can be specified in BNF. Let's see that I am writing a rule in BNF. Variable is equal to expression. Now I am using some assignment operator derives. Now assignment operator derives or assign derives variable is equal to expression. So this is written in BNF grammar. Here there are something where you cannot define in this BNF grammar. The something is what? You are not telling what kind of variable it is in the BNF. Because there are some characteristics of the structure of programming language that are difficult to describe in BNF. Let's suppose that I am not talking about the data type of this variable, that I am not talking about the what are the data types of this expression. And to be truly that when you are taking a variable over here, this variable what you are taking here and what is the expression you are taking here will definitely have a data type. Take any programming language that they will have some data type. And the data type what you are defining here, the data type what you are defining here may be different data type. Then what we'll do is we'll take type conversion techniques. If the data type what you are taking here, what you are assigning here is the same, that means actual data type, expected data type are same, then we'll not have any type conversions. So truly I am talking about the data type of these. Now this is what more structure. I have used a word in the previous slide, that is what more of the structure of a programming language. The structure of a programming language is always includes defining about the variables, and this is what static semantic. Now, so these problems exemplify that categories of language rules called static semantic rules. Static semantic rules. Many static semantic rules of a language state its type constraints. When I am talking about data type of actual data type will be written over here. If I write variable is equal to expression, now it is symbolically representing, this rule will derive you a is equal to a plus b. Now let's take here it is c. C is equal to a plus b. A and B are my input variables, correct? So these are called as what? Actual data type variables. Fine. because I'm defining A and B and I'm taking the values into it. C is my expected data type. Now here we have to understand something, that static semantic rules of a language state its type constraints. In the previous question paper, this question is direct question, explain about static semantic. In turn you have to talk about attribute grammar, because attribute grammar is exactly what the mean of static semantic and dynamic semantic. So now from this presentation we'll come to know about static semantic. Static semantic is what? It's having set of rules of language state its type constraints. And static semantics is so named because the analysis required to check the specifications can be done at compile time. Now there are some basic concepts what we have to understand. Attribute grammar or context free grammar, to which have been added attributes, attribute computation functions and predicate functions. These are what basic concepts which are involved in attribute grammar. Now these are what we were discussed just before, right? If you take an example, now I'll give an example to understand in better way. So I'm taking some example. Assign derives variable is equal to expression. Now look at this. Here, this is what the rule. I'm saying this rule is syntax rule. I did not do anything for this rule. This is the rule what I have taken from BNF. Standard rule. Now, this rule cannot give any kind of description about the rule. That means this grammar will not talk about any type constraint. So I'm going to write a semantic rule from this. What is the semantic rule? It is static semantic, because in the previous slide we come to know about semantic rule. Static semantic will give you about the type constraint. Fine. Now this semantic rule will defines about the type constraint, that is expression dot expected type variable dot actual type. Now what is the semantic rule? This semantic rule will give you about the complete knowledge regarding type constraints. So an attribute grammar is a grammar with the following additional features. Now those features are: associated with each grammar symbol x is a set of attributes a of x. The set a of x consists of two disjoint sets s of x and I of x, called synthesized attributes and inherited attributes. Synthesized attributes are used to pass semantic information up a parse tree. Inherited attributes pass semantic information down across the parse tree. If you draw a parse tree for this, then what might be that parse tree? Equal to, so first of all we'll write assign variable is equal to expression. Now, so what is synthesized attribute? Synthesized attributes are used to pass semantic information up to the parse tree. Now let us suppose that variable is equal to a and expression is written as some a plus b. Let's understand. Now, so synthesized attributes will pass the values up to the parse tree. Inherited will pass down to the parse tree. So this is about synthesized and intrinsic, which are part of attribute grammar, and synthesized inherited intrinsic attributes. So I told you about synthesized attributes of what will pass the values up to the parse tree, inherited down to the parse tree, and the most important, Intrinsic attribute. Intrinsic attributes are synthesized attributes of leaf nodes whose values are determined outside the parse tree. So I'll take a grammar, end of this slide, I'll take a grammar and I'll give you the parse tree. I'll show you how the values are moving around the parse tree. That also we'll see. Now, let's take some example to understand what is about this attribute grammar. Now here I have taken an example, procedure definition, procedure name. This is what the first rule. Procedure body and procedure name 2, second rule. Now, so here I'm writing a predicate function. The predicate function is what? Procedure name from rule 1, that string double equal to procedure name 2 dot string. Now, so here the string attribute of procedure name denoted procedure name dot string is the actual string of characters that were found immediately following the reserved word procedure by compiler. Now, notice that when there is more than one occurrence of a non-terminal in a syntax rule in an attribute grammar, the non-terminals are subscripted with the brackets to distinguish them. Neither the subscripts nor the brackets are part of the described language. In this example, the predicate rule states that the name string attributes of the procedure name non-terminal in the subprogram header must match the name string attribute of the procedure name. This is about predicate function. Now, I'll show you a complete example, an attribute grammar for a simple assignment statement. Now, this is what? This is BNF. Each syntax rule is BNF. Each semantic rule is what? Static semantic or attribute grammar. Now, syntax rule is what? Assignment derives variable is equal to expression. Now, the semantic rule should talk about the type constraint. Now, expression dot expected type, variable dot actual type. Now, semantic rule is what? We are having some expected data type and we are having some actual data type. What do you mean by this? The second rule, variable 2 plus variable 3. These are what my inputs from where I am taking, from lookup table I am taking. Now, expression dot actual type, if variable 2 dot actual type is integer and variable 3 dot actual type is integer, then it is integer or else it is real. Correct? Now, we will be closing this static semantic by writing if block. Now, what I am predicating from this, that we were seen in the earlier basic concepts of attribute grammar. Those are attributes which we will talk, attribute compute functions and predicate functions. From each of the rule, we'll write attributes, we'll write attribute computation functions and we'll write predicate functions. The predicate function is what here? I'm predicating or I'm predicting expression dot actual type is equal to expression dot expected type from this computation. And the last syntax rule and semantic rule is what? Expression derives variable. When expression actual type and variable actual type are same, then the actual type expected type is predicted by the attribute grammar. Now, syntax rule, variable is equal to ABC. These are the actual type from where you will take the lookup table. So, this is about attribute grammar with type constraints. Okay. Now, so this is an example how the way parse tree is constructed. So for this grammar, what are synthesized attributes? Synthesized attributes are used to pass semantic information up to the parse tree. Inherited is down to the parse tree, and intrinsic attributes are the attributes are synthesized attributes of leaf nodes whose value are determined outside the parse tree. Okay, and this is about complete attribute grammar. So here the tree is constructed along with the semantic rule. So next video we'll discuss about dynamic semantic. Thank you all.